first thing we're going to do is tackle this challenge, which will make use of all the dplyr and tidyr stuff we've done so far, and ggplot too. So the challenge is we have a question: do properties appeal to business, traveler and tourists alike? Right? Do business people give high review scores to properties that tourists also give high review scores to? Or do they appeal differently? Say, do certain properties appeal to business travelers and certain properties appeal to tourists? So for each property, you need to calculate the average review score given separately by business bookers and tourists. And then we're going to visualize these in a scatter plot. So you want one axis to have the review score given by business bookers, one axis the review score given by tourists, and each point in the plot should be a single property. Good luck. For those who came in late, this is the challenge we're working through. Do properties appeal to business travelers and tourists alike? So you need to calculate the average review score for business bookers and tourists per property and plot these against each other. For time, I'm going to start moving through the answers a little bit, but check that you got the first part. Or at least an equivalent. So here I'm giving a review by type. So I'm taking the data frame, I'm grouping by the property ID and for business. So every combination of property and bookings coming from tourists or business bookers. And I'm summarizing to get the average review score. So that's the first part. I think I'll move to the second part already and then leave a bit of time for anyone else who's trying to plot. I'll let you digest this. So remember, I had one row per review and for business or not. But I want to plot these things against each other. So I want x-axis, say, to be business and y-axis to be tourist reviews, which means I need these things in separate columns. And that's where spread comes in. This mutate here, you don't have to do it, but what you'll notice is that if you spread without doing this, you'll get true and false here. And actually I can, you know what, let me show you. It also means I can put all the code together in one spot. So here's the first part. Here is the second part. And I'm going to comment out this mutate line. And you see you get true and false here. That's fine, you can work with this, but there are a few things to know. First of all, the column names get surrounded in backticks. And this happens whenever you use a column name that's not compliant with data frames. The other thing is they're just not really informative, are they? If you looked at this, you would have no idea what true and false were. And it's fine if you're, say, doing work by yourself and you know right then and there, but my preference is to always be explicit, use something that you can understand, you don't have to think about, which is why I include this mutate line here, which converts the trues and falses into business and tourist. So that when they get spread, the column names are easy to work with and they make sense. Well, more sense than true and false. Yeah. Why? Okay, good question. So this was the first part that we got, a summary. So for each property ID we have business and review score, not business. What we want to do is plot those against each other on two axes. Now to do that, they have to be in separate columns. We can't use this data structure to create that plot. So maybe when I go to the plot part, you'll see You'll see why. I see some people getting through this, so I'm going to let that there. If you're fine with this, try and make the plot.
Is it possible to do this in a single pipe, like in a single set of pipes? Because I'm trying and I get you can't mutate your business because it's a grouping variable. Is that why you have it separated out into two steps?
So if I chop this out like this, works for me. Maybe one of the guys can drop by and help. Yeah, but while that's happening, I'll mention something else. You definitely can do this all in one pipe if you're so inclined. And this is really just a style thing, how you like to work. Me personally, I like to break my pipes into logical chunks. So here is where I'm getting a summary of the data I need. Here is where I'm converting it into a format ready for plotting. You can do whatever you want. You can put it in one massive pipe. You can break it up into smaller chunks. I like to sit somewhere in the middle where the chunks are relatively healthy but make sense. Also, you can start to put comments, summarize, and so on. That's if you want to be nice to yourself, you leave comments. Is everyone laughing? Like, no one comments their code, don't be ridiculous. And that's, the last part's pretty simple from there. Right? We're just taking this data frame with the two columns, and this is why you need the two columns. And I'm plotting the tourist review scores against the business review scores in a scatter plot. So it sort of seems maybe there's definitely a big center around here, but we have tails for both groups heading down this way. So these properties, for example, they're being given high review scores by business bookers, but very low review scores by tourists, and you have a similar group over here. So there's probably some in common about properties, but also a difference in preferences. Simulated. That's it for Tidyr. Okay, so we covered, let me think, reader, magritter, tibble, dplyr, ggplot2, Tidyr. Am I missing anything? Oh yeah, from Tidyr, gather and spread. Thanks. That's pretty chunky, right? And we've been using these things the whole way through, and hopefully now, again, you can start seeing that they're solving different problems, but you might not even realize which package you're using because they all have the same sort of syntax, right? It's all around data frames in, data frames out. You don't have to use quotations around column names, right? You can just flow really easily in the data manipulation, munging, all the way through to visualization. And this is definitely one of the strengths of the Tidyverse, is the ease with which you can move through the entire workflow. So at this point, we're going to take a little bit of a sidestep away from data frames, but we will come back to them and use a package called purr. A show of hands, who's familiar with purr? Okay, finally the number of hands is going down. Excellent, good. So we have the whole second half to get into this, which will be new for pretty much everyone, or at least the people who didn't put their hand up and meant it. And very quickly, I'll say purr and iterations, there are lots of ways to think about it. The technical thing we're talking about is functional programming. I can't remember who, but one of the nice descriptions I heard was that it's a way to repeat yourself elegantly. And apologies to the person who I'm not citing by name. But I think it's a nice way to think about it. It's when you want to do something over and over again, but in a really expressive way. It gives you a lot of power. We're going to set up in exactly the same way we've been doing. We've got our two data sets, we've got the Tidyverse loaded, and this time you must fall in love with the apply functions cheat sheet. Per. This one is all about per. Without a doubt, my favorite thing about this package is the hex sticker. Right, it's so cute. The RStudio guys can step in and defend themselves, but they all seem to have this weird association or love of cats. Is that fair? Yeah, sort of, yeah, maybe. There's a lot of cats, and it's the only hex sticker that's hand-drawn as far as I'm aware. This is totally irrelevant to your R skills, by the way, but I really like it. My next favorite is 4 cats. Let's see if I can get it happening here. No. Tidyverse. It's another Tidyverse package. Very clever. It stands for factors. It's an anagram. And it's 4 cats, literally. Anyway. There you go. Useless education. Let's get back to it. If I can find the slides. Okay. I'm going to take this again because I'm being really naughty. Consider this a little bit of advice whenever you work in this sort of way. You might have a whole environment full of stuff. It never hurts to clean it up. Get rid of everything, start fresh. You can go session, restart R as well to unattach all your packages and everything. Because I see a lot of people like loading lots of packages and then suddenly one day they start using functions and they stop working, and it's because there's a conflict with a package they loaded up like 3 weeks ago. So anyway, this is just a good habit to be in. Session, restart R, and start again. So I'm just going to start with the Tidyverse and my 2 data sets. Okay. We have a thought experiment. You can try this out yourself. How would you hash encode property IDs? So imagine that these property IDs were identifiable information, maybe about people that we don't want to people to be able to use to link to an individual or something. So we want to hash them, right? Turn them into a sort of random collection of letters and numbers so that they're not identifiable. There's a function in a package called digest, also called digest, which does this. It hash encodes objects in R. How would you do this for every property ID? Have a try, or at least have a think about it. It does. Test it out. So you might have tried to do this in a few different ways. If you were being true to the workshop so far, you would have tried mutate, but I don't mind if you tried it another way. If you did something like this, so you said, all right, property ID equals digest property ID. Have a look at what happens to property ID. They're all identical, all of them. Right? That is definitely not what we want. And I'm just going to do it myself here. And the reason is that this function is not vectorized, right? It won't take a vector and be applied to each element. So if I said digest 1, it gives me a hash. But if I say digest, this vector 1, 2, 3, it only gives me one hash back. Right? It takes that whole vector and it hashes that object. It doesn't give me a hash for each individual number. So what are we going to do? We could write a for loop. Now this is a bad version of a for loop, but it is pretty much how everyone writes for loops when they start learning R. Right? I'm seeing lots of nods. I did this. You've all done this. Many of you probably still do this. Do not worry. Do not feel bad. I'm going to teach you how to make it better. And also why it's not good. But this is very common, right? We declare some object that's empty, like an empty vector, and I say, hey, for every ID in that column of property IDs, take this hashes object and append to it the digest of the next ID. So we get a vector of what we want. That's nice. And then maybe we could use this object in a mutate call or something. But hey, Simon, I hear you say, no one said that. Loops are really slow, aren't they, in R, right? Doesn't everyone tell me that? I tell them I use R and they're like, loops are slow. Not really. The problem when you write loops like this is that R doesn't know what you're creating. It's actually, this is null. Right? So it has no idea of what information is going in here. Is it going to be a character string? Is it going to be numeric? Is it going to be Boolean? And it has no idea about the length. And every time you go through the loop like this, it has to make these decisions, and it has horrible usage of memory. And so writing loops like this is slow. It's much better if you pre-allocate the memory so you know how big your output is going to be and you know what type of output you're going to get. So in this example, right, I'm saying n, the number of items I need to create, is the number of rows in my data frame. And this time I'm creating hashes as a character vector, so I know I want character strings back with a particular length. And then this time I can go through and just replace each element with the hash. This is way faster. Don't worry, you don't have to copy this down, it's in the slides. If you don't believe me, here's a very quick proof. Here I'm just taking 50,000 numbers. It's really not much. And filling in two vectors with those numbers, 1 to 50,000. The first way is with the empty vector that gets grown. Check out the time on that. Right? The second way is once I've pre-allocated. This is why people think loops in R are slow. Right? Just because for the most part you may not have been taught or not aware of what's going on under the hood. So this could be a little like mind-blowing moment for a few of you. Let's forget about loops and move to per, because per takes care of these sort of issues for us. We're going to talk about the map functions. What do the map functions do? They iterate through each element of a vector or list. I'll come back to lists just quickly for those who aren't familiar. It's a very flexible structure in R. It's a sequence like a vector. There's object, 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 but those objects can be anything. Right? With vectors, they have to be all character or all numeric or all of the same type. In lists, you can have character, vector, function, matrix, data frame. Right? They pretty much hold whatever you want them to hold. So the map functions iterate through each element, whatever they are, and it applies a function each time and returns something each time. If you're familiar, if you've done this in base R, you're probably more familiar with the apply functions. Just quick show of hands, who uses apply, lapply? Right. So you can consider these the alternative. And there are some big dangers with using those functions. sapply, for example, tries to coerce the object it returns into something simple, And that makes it very slow because each iteration it's working out, oh, can this be a matrix? Can this be an array? Can this be a vector? Right, so these are Tidyverse alternatives to those family of functions. Right, the bonus, it takes care of this whole, that thing I showed you with the loops where you should pre-allocate, it handles that. And you also know the output you're going to get back. So like I said, with sapply, you're actually never quite sure what it's going to give back to you. Could it be a vector or a matrix? I mean, I don't know about you, but the way I used to use it when I started using R was I just threw it in and crossed my fingers and said, hey, what am I going to get back? Sound familiar? Yeah. With the per functions, you upfront declare exactly this is what I want to get back. So before you run anything, you'll know what you want to get back, unless you get an error. That's your fault, not per's fault. Okay, so this is another way to think about it. You have a vector or list, you map, and you apply some function, and that function gets applied to each element separately. This is exactly what we want to do with the digest thing, right? We want to apply digest to each element individually, not the whole thing as one unit. And then each of those returns something. Okay. There are various ways to use these functions. I'm going to start with the most general. Like if you forget everything and you have to come back to one way, this works no matter what. So you have an list or vector. Sorry if it's a bit small. And you apply map to it. So the first argument is that object. So here's just a vector of 1, 2, 3. And I'm saying map over 1, 2, 3. And then I'm going to declare something called an anonymous function. If you're used to using lapply or any of those, this is the same. Wow, that's fancy. It's the same as when you do this. You do something like this. I'm having a lot of errors here. Right? This is called an anonymous function. If you're not familiar with it, just don't worry about it. So to do that, you declare a tilde, and then you can use the dot to represent that object on each iteration. So if I go back to the visualization, right, it's like saying these blue squares are the dot, right? Each iteration, what am I applying a function to? And in here I can do whatever I want, write whatever code I want. So here I'm just adding 1 to each element. Okay. Here we go. We're starting to get closer to what we were trying to solve. Now I'm saying map on X, tilde, and now I'm going to use the tilde and the dot, apply digest to each element. And now I'm getting a hash for each element separately. Cool. We're on the right track. There's still something a bit annoying about this though, at least for what we want, which I'm hoping you can see. We're getting back a list. Yeah, this is a list. So if you're not familiar with lists, this is a 3-element list, and within each element is just a character string. We'd much prefer a vector. Fortunately, there's a whole bunch of other functions to do this for us. And so remember, that whole idea of we need to know up front what it is we want back. This is where this comes in. So map will always return a list, no matter what. Map will always return a list. If you want something else, you need to use another version of map. So it's map underscore, and then the type of vector you want back. So map underscore double saying I want a vector back of real numbers. So here I'm mapping over X, and I'm just saying, hey, multiply each element by 0.5, and I get a numeric vector back. There's map underscore logical, map underscore char. Hey, this is what we want. There's a character vector. I think, I could be wrong, but I think these are all on the same help page as well. Yeah. So if you ask for help on any of these, you'll see there's map logical, int, double, char. There's also these fancy data frame ones and a whole bunch of other stuff that I'm not going to teach you in this course. They're for you to explore. Okay. So we have map. Remember, map returns a list. If we want a vector back of a specific type, it's map underscore and then the type. Yeah. With function, I don't think so, no. We can try, but I'm pretty sure you can't. If I just say map. You mean like this? Yeah. Ah, there you go. You can. Nice. So if learning the map part was enough for you and you want to blend, there you go. That's nice. I like learning things. I'm going to stick with the tilde for the rest of the slides, mainly because I made the slides and I don't have time to change them now. But you're welcome to use the alternative. Good. So I want to show you a few shortcuts now. Like I said, if you forget all of these shortcuts, just remember you can always use that anonymous function to do whatever it is you want to do with the tilde or the function and the dot. So if your function takes the dot, if you're just applying a function that exists in your environment and the dot is the first argument, you can drop the tilde and the dot altogether. So you can just say map char x digest, and then you can provide additional arguments. Right? I'm showing you this because once you're familiar with Per and you work with other people who are using it, you're going to see it a lot. It's much easier to write this than this. Two other shortcuts very quickly. If you're iterating over a list that has named elements, so this is a list of two vectors. There's vector 1 here, vector 2 here. Both of them have names A and B. And if I just want the element called A from each object or each element, I can do away with all of these double brackets and everything and just say A. I want A. Okay. And same if I want it by position. So if I want the second element from each vector, I can just use 2. Okay. Once again, these are just shortcuts. You can always default back to the tilde and the dot. All right. Back to where we started. Use a map function and digest to hash encode the property IDs. And try to use mutate, in the spirit of the tidyverse and all. So quickly, this is the wrong answer that we probably intuitively went for at the beginning. But it's what we want, right? We want to apply this function to each of these. So we're going to map through property ID and apply the digest function. Now I'm missing something. Maybe you can see what it is before I run the solution. If I run this, property ID, what the hell is that? That's a list column, right? This is not what we want in this case. We will in the next set of slides. But it's because, remember, map returns a list. We just want a character vector back, so we've got to put map underscore char. There we go. A unique hash for every property ID. Did I put the answer? Yes. Okay. Any questions about map, if you're brave enough in public? Yeah. I know him, he can wait. Sorry, Mark. Oh, why do the hash encoding? I mean, imagine, for example, you're doing research, maybe medical research, and you have patient numbers which can be linked to those patients, and you want to share that data set with someone else, but you can't have identifiable information, so you may want to do something like a hash to hide that. Would that be a, I mean, yeah. Sorry, I'll just come down here. Yeah?
So before you were doing group by, that would allow you to run a function on different groups.
Mm-hmm.
If you were to group by property ID, you then run digest, it would give you different hashes for all of them.
So group by and mutate?
Yeah.
That's an interesting idea. It wouldn't work exactly as you expect. So first of all, I don't know if it would work at all. But even still, imagine you ended up with a group where you've got a data set of maybe 10. There are 10 bookings for this one property. And so when you apply digest on that group, you're getting a hash of the 10 combined, not of the single one. So if you then want to turn that one into the hash, it won't work. Yeah. Sorry, I think up here next. Yes. It would. Yes. No, it's not totally random. So just for those of you who want to start hash encoding everything, it's replicable. So it will always convert the same object to the same hash. No, the order or its location is irrelevant. It's the value there. Did you have a same question? Okay. Ooh, I picked a good function to use. A lot of questions about hash encoding. All right, cool. We can chat more about hash encoding over a drink later. I don't mind. Anything else while I'm getting set up? Okay. So we're entering into the last hour, and I'm going to teach you a little bit more about iteration with data frames. Then we're going to finish off the technical piece with a big challenge that really combines everything. And then there's a bit of an outro. I have a feeling that we might finish a little early, so that's nice. But do feel that you can take your time, because I think at this point it's going to get much more complex than it was in the first half. Okay, same setup as before, right? Tidyverse, 2 data sets. We're going to full join the 2 as well. If you want to be good, you can restart your R session. And you can get set up while I talk a little bit. Why combine iteration and data frames? So you've already seen us combining this concept of iteration to do the hash encoding. That's because we couldn't vectorize our task, right? So we just have a technical sort of limitation there that we need to make use of. The other thing which I think is less obvious to talk about, but it's much easier to see in practice, is that we want to keep things together. And in the challenge that we're going to do towards the end, we're going to start creating regression models for separate groups of our data. Now, traditionally, when I started with this, and I see a lot of people doing it, if they want to create very complex objects, say like regression models, for lots of groups, they might have a vector over here that has the order number, like the sequence, 1, 2, 3, blah, blah, blah. Then a list of data frames over here with the data for each group. And then the regression models in another list over here, and then the output over here, right? You end up with like 10 different objects that you assume are ordered in the same way, and you can loop through them all with some big loop and go, hey, for the first element in each of these objects, pull out what I need. This is very unreliable, right? With a data frame, you can bundle all these incredibly complex structures together, and so you know that everything in the same row belongs together. Right? I can have a row with city names and regression models and output from those models. And if that sounds a bit bizarre to you, like what do you mean a regression model in a data frame? I'm about to teach you. List columns. I think, just quickly, it's Jenny Bryan who has an awesome slide deck about list columns, and she uses lots of Lego. Definitely recommend finding that because it looks really nice as well, other than being informative. So we saw this before when I used map. And you can try this out yourself. Our data frames can have a list for a column, right? So usually you think of the columns as vectors, like numbers, integers, characters. You can also have lists. And remember, lists can hold pretty much anything in R. And tibbles print them out really nicely. If you ever try to do this with a data frame, not a tibble, I'm telling you now, it's a mess if it prints at all. So here I'm taking the properties data set, and there's a column in there called facilities. Oh, my screen is too narrow. So it's a character string of the facilities that each property offers to customers or travelers. And we can see there's a comma separating these facilities. Maybe I'd much prefer if each of these was a vector, right? Because if it's a vector, then I can do things like find whether one element is in there, I can count the length, I can work with these really easily. So there's a function called str split or string split, which I'll just quickly show you. It takes a string, and you can provide a separator, and it will split that string into a vector. If you can see here as well, it returns a list. Conveniently, it's vectorized for us. So we can apply this function to the whole facilities column. We can say, hey, facilities is string split, facilities, and split on the comma. And we now have a list column where each cell is a vector. I'm going to override properties with this. Don't worry too much if you don't. But I want to show you a little tip. If you ever start working with list columns, and I would suggest you do, or you come across someone else's code that creates list columns like this, and you're like scratching your head and thinking, ugh, what on earth am I looking at? Just peek, just take a look at the first cell. Right? You can say properties $facilities, get me that column, and just look at the first element. Ah, it's a vector with these elements in it. Right? Just take a peek at one cell. That's all you got to do. I do it all the time. Because it can be hard to work out what's going on from this. This is pretty informative. These tibbles are telling us that they're character vectors of length 6, 7, 1, 3, blah, blah, blah. But as we go forward, we're going to use more complex objects, and you really have no idea what's going on in there. Oh yeah, I should have put this way earlier, but this is just a reminder that lists can store anything. So we've got a nice setup here where every object in here is a character vector, but that's not what we're limited to. So this is a list with a numeric vector, a character vector, a function, a matrix, which is off the screen, anything. Okay, so now that you've got this list column for facilities, try and add a column that contains the number of facilities per property. So you want a numeric or an integer column that is a count of the number of facilities that each property has. And this was the setup in case you missed it before. So you can start from here and then try and work it out. Just something important to know. This probably won't work if you are using just a plain data frame, not a tibble. So if, for example, you use read.csv instead of read_csv from the reader package, you will hit an error. So another nice advantage of tibbles here, it gives you a lot more flexibility in what you can do with a data frame. Is there an answer? Yes. Oh, tiny, tiny, tiny. So we took the properties and we're mutating to add a new column, n facilities, and I'm mapping over this list, and I know I want an integer back each time, and that the function that will count the number of elements in each vector is length. Right. And you can see these numbers match up with the numbers that the tibble tells us about. Yes? Length? Yeah, so we can try it out. See if I've got it here. So like this. So take a look at what comes back. And first of all, they're all the same. They're all 4,178, which is exactly the number of rows in the data set. So what you're doing here is saying, I want the length of this column. And that column is a list with this many rows. So it's being applied to that list. So you really need to map through and apply the function to each cell individually. Yeah. Does that answer the question? Yeah. You're about to show me something really fancy, aren't you? Like that? Nice. Shortcut. Let's do this. Love it. So lengths blows my test out of the water, or at least my answer. And you can choose, right? So if you use the map, then I hope you learned a little bit more about the map and how to apply functions iteratively. There are often cases like this where there are functions designed for these purposes. Yes?
Could you use row-wise?
Row-wise? Yeah. You can use row-wise. I'm Not sure about the advantages of it. I guess it would be an alternative way to do it. Yeah. But yeah, in this case you could for sure. Yeah. So there's an opportunity if anyone else wants to open up a nasty issue on GitHub or a nice issue on GitHub. All right, let's start getting a little more tricky. List columns. They can seem a bit odd at first. They take a bit of time to wrap your head around. There's no doubt about that. But they're worth the effort. Very quickly, from this point on, I will be using two statistical models, the t-test and linear models, regression. If you're not familiar with these, please don't hesitate to ask for help when the challenges come up. But I'll do my best to explain them as well. See if you can work out what's going on here, or what I'm trying to do, and why it's not working. No. So very quickly, what I'm trying to do is saying, hey, for every check-in day, like Monday, Tuesday, Wednesday, Thursday, Friday, and so on, do we see a significant difference in the average review score given by tourists or business travelers? And that's what the t-test does. It compares the average review score for two groups. So in this case, business travelers and tourists. And I'd like to do this separately per check-in day. I have reason to believe that the results differ by check-in day. Now, you'll get back an error if you try this. Column t-test must be length 1. It's off the page, so let me run it in my R and see what it says. Blah, 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 blah. Not 9. A little piece of advice, if you're not aware, if I just do, I'm going to use one of the built-in data sets, mtcars, just to show you this, and I save the results of a t-test. When you print a t-test, you get something like this. This is one of the sort of misleading things about base R. The t-test is actually a list. It just prints like this. Right? So if I look at the length of this object, there are 9 things in there. What are those things? Look at the names. Right, this is a list with 9 named elements. So don't be fooled by this well-designed print. It's a list. And so what's happening is that when you call the group by, and remember, summarize wants 1 element per group, right? But the t-test is giving it back 9. And so this doesn't work. There's a simple fix, though. You just wrap it in list. Wraps those 9 things into a single list, and this is what you get. Now check that out. I have per day a t-test stored in a cell. I don't have all these objects scattered around my memory. It's really nicely bundled. I could extend this out to be working with many other combination of groups just by adding to group by. It could be check-in day, destination, traveler type, right? And this code will work perfectly well. It doesn't take much to extend the capabilities here. And it's a list column. And this is why I said before, if you start seeing list columns and you're not sure what's inside, let's just say I store these results as X, and I see this and I think, oh, what the hell is S3 Ttest? Right? I can just peek at the first element. Ah, there we go. That looks familiar. That's a t-test. And surprise, surprise, we can keep going, right? So I've fit my t-test, and now I can pipe again and add a p-value column. And because a fitted t-test is a list with names, right? Before we saw the names I printed here. In here, there's something called p.value, which is what every statistician wants. I can map through these complex models, right? Map through the t-test. I know I want a number back. A p-value is a number between 0 and 1, and just ask for the p-value. So for each check-in day, I have the p-value of the t-test, neatly bundled up in a data frame where every row belongs together. And hopefully you can start to see it's really not a stretch to go from this to a plot. I can pipe straight into ggplot and plot the days against the p-values or something like that. And think about what that would have taken had you not been using the Tidyverse. Here it's sort of 4 or 5 lines of code. All right, bringing it all together. This is our grand challenge. You can tell it's grand because I put so much text on the slide. We believe price, demand, and property type affect properties' average review score, and that the relative importance of these factors differs between cities or destinations. So here is your challenge. For each city, separately, fit a linear model, which is the function lm, and if you're not familiar with it, we can help you out. And you're going to try and predict the average review score for each property with the average price per night, the number of bookings stayed or cancelled, and the property type, whether it's a hotel or apartment. Then compare the predictive power across the cities. Little extra challenge, if you can squeeze it in there, is we don't want properties that don't have a lot of data, right? So remove properties with less than 2 non-missing review scores. And my PR department once again wanted me to remind you that the data is simulated. How many times have I said it? I think they're okay with it now. You guys get it. This is a big challenge. I've broken the answer up into chunks. So get started. I'm going to put a piece up every so often. You're really going to have to use everything that we've covered today. And oh yeah, the linear model thing, if you're not familiar with it, the syntax looks like this. You have your, the thing you want to predict on the left, so like your y variable, or in this case it will be something like average review, whatever you want to call it, tilde, and then your x variables like this. And if you have a data frame, you can add it here, but you probably won't need to do this. So I'm going to leave the challenge up there, and we'll be around to help whoever needs. Please feel free to continue working. I just want to talk through this code if for anyone who's still trying to work out what's going on in this first part, and then I'll show the answer for the next part. So yeah, don't hesitate to keep typing and working away. Here what's happening is we're joining our 2 data sets, and I'm grouping by 3 things: destination, property ID, and property type. And a lot of people ask, why are you doing all this grouping? You could just group by property ID, because that's what we need, right? And destination and property type are linked to the property ID. So you can do it just by property ID. So let's see what happens. We'll continue on. The next part is the filter. And this is similar to that problem we had before where I said, hey, maybe you want to filter with groups with only so much data. And so this part here is saying the sum of the non-missing review scores is greater than 1. So there's at least 2 or more non-missing review scores for this group, which means any properties that don't have 2 or more non-missing review scores will be discarded completely. So that's the filter part. Then we get to the summarize, which is pretty straightforward. We're just getting the average review score for the property, the number of bookings, and the average price. Now remember, we want to do this all separately per city as well as per property type, apartments and hotels. We want to use that in the regression model. So if I run this, of course, we're missing those things right now. How could you get them back? There are lots of ways to do this. So one is, well, we could just left join the property data set again. It's a bit of a crazy way to do it, but you could do it like that. I must have done something wrong. I'm missing something somewhere. Okay. That's weird. Wow, it really doesn't like that. Something in a comma somewhere. It's weird. Okay, it was just to do with the auto completing. Right, I could left join it on because it knows the property ID is there and it binds everything back. So I get that, but I also get back all the other stuff that really I don't care about. That's one way to do it. The other is to get it out of the summarize, right? So if I just look at everything before summarize, it's in here, but think about what's happening. I have a group of data per property ID. So maybe I have, let's say, 10 rows for one property, and I want the destination. Right now, the destination is repeated 10 times. So if I put in here destination equals destination, oof, that's a bit rough. It's very difficult typing on this angle. Doesn't work, right? Destination must be length 1. So I have to get out, just say the first element. That's a way to do it. Personally, I find it a bit ugly, and you've got to remember what's going on. I don't like it. But because each property ID is tied to a single destination and property type, we can group by all three of them. It doesn't matter that those groupings are still going to be the same as, right? This will give us the same groupings, but this will return the destination and property ID columns for us as well, right? So that's why I do it like this. There are other ways to do it, but something to think about. So that was that first part. Here's the second part, if you haven't fit the regression model yet. I'll just give you a couple of minutes and then I'll go through it because I think most people have, by the looks of it, sort of getting through it. Again, if you're comfortable, you want to keep working, go for it. I'll just talk through this one. First thing I noticed is that I'm breaking my own cardinal rule and I'm just calling everything D. And I'm opening myself up to mistakes. Yeah, I'm seeing a few people nodding and going, yeah, that's right. Don't tell us what to do. So I've got all the data I need here for my regression model. In the first step, you know what, this is getting to me. I'm gonna fix this. You know what, this is property data. Property data. Okay, and then we're going to say city models. Okay, so with the property data, remember we wanted to fit a regression model per city, per destination. We happen to have 3 in our data set, but just recognize that this could have very easily be applied to hundreds or thousands of cities, right? It doesn't make a difference for the code here. So we're grouping by those destinations, and then we're summarizing, and this was just like our Ttest, right? We're saying, well, we want this list back, and we run a regression of the average review scores being predicted by property type, number of bookings, and the average price. And we get back something that looks like this. Again, we have this weird looking list column, and if I'm not sure what is going on, I might just peek into the first cell of fit, Okay. This is what I was expecting, a regression model. So the last part before we get into visualization was getting the R² out. I will admit I was a little bit mean with this last step. So the people who know why I was mean are grinning. The people who do not are just saying, why would you be so mean? Give me the answer. I couldn't work it out. And this is a problem with R that you had to work out. You cannot just get the R² value from a linear model. Right? So when we look at this fit, there's coefficients here. There's a formula. This too, like the t-test, is a list without names. But either way, it doesn't have the R². To get the R², you have to call summary. Whoa, jeez. And I'm sorry, this was mean. Oops. So if you're used to doing regression in R, you're probably very familiar calling a summary function, and it shows you a table of all the coefficients and the p-values. And down here, we've got the R². This is something a bit messy with regression in R, is that to get this R², summary actually does computation in the background. Right? It's not just a display. It's not just output. It actually is doing computation as well. So here's the trick. You had to map through this list of fitted models. And the R² is a number between 0 and 1, usually. But you had to get the summary of it first, and from that you could get the R². So I'm sorry everyone if that was a little too tricky, but I hope at least you could think about the idea of mapping through these fitted models. So let's just put this here, city models. Now you can do this in all sorts of ways, right? Just to show you some other examples. This is using the anonymous function to run the summary, get the R². You can, if you're not sure, do intermediate steps. So I might say, well, I want to get the summary first because I know I need to get it. So I might map through the fits and get the summary. Summary. Like this. Right? I could do it like this if I wanted to be a little more explicit and know what I'm doing step by step. And then I could get the R² from each of these. Map double from the fit summary, whatever I called it. And this time, because the summary object is a list with names, and in there is the name r.squared, I can just do it like this. Same thing. So that's another perfectly legitimate way to do it. You end up with an extra column. Totally up to you. It also shows using map in a slightly different way. Right? The other way you had to use that anonymous function. This is another way to do it. All right, we get our R², and then, just like before, we can go straight into a plot. I can say plot the destination against the R² using geom_col in this case. Just puts a bar. Super simple plot. Apparently, our model is fitting the Amsterdam data best. That wasn't by design, I promise you. Tokyo came under Brisbane. It doesn't matter. But I'm going to take this and put it here. And I just want you to have a look at all of that together if you don't have it there yourself. That's it. Right. So have a look at what we did. We had these two data sets. We joined them up. We summarized for a bunch of different groups. And we even discarded groups of data that weren't sufficient for the purpose of modeling. We then fitted regression models to different groups, right? Very much in this tidy data frame structure. So everything's still neatly packed together, and we could move through that, extract the information we need, still in the data frame structure, directly into visualization. This is no easy feat, right? And I think if you're still new to all these tools, it's easier, of course, when you're in a workshop and you have answers there and everything. But if you persevere and you learn to master this skill set, you can work incredibly efficiently, right? That whole data science workflow becomes very easy to navigate by connecting all these tools together. I have another bonus. That's nice. This is just for the people who are into modeling. There's a package called Broom. It's also now part of the Tidyverse. And it takes these messy models like regression, Ttest, and all this stuff and gives you back data frames of information, right? Already, I think you can tell, like this sort of stuff, this is really not very nice and it doesn't integrate well. Broom lets you do it really well. So if we wanted to do something similar with Broom, you'd have to load Broom up. It gets installed when you install the Tidyverse because it's part of the Tidyverse, but it's not loaded with the core packages, so you've got to load it separately. And where is the fitted model? City models. So here we have that data frame with, say, the fitted models, just the fitted models. And before we had to do this summary, R squared, blah, blah, blah. Broom has this really nice function called glance. So if I map through each fit and glance, it pulls out summary statistics for the model as a data frame. And I took this out originally from my workshop slides, but there's this function called unnest. If you have something like a data frame or a tibble in a list column like this, which you get when you start using Broom, you can unnest it, and voila. Per destination for each regression model, R squared, adjusted R squared, sigma p-value, and so on. And there's a few functions for Broom that do really beautiful stuff. So this one pulls the summary statistics that we want. You get one that pulls model parameter estimates like the coefficients, and one that binds predictions and errors onto the original data. This is for the statisticians and modeling people. I'm not at all mentioning Broom because I had a pull request merged last week. All right. I think I have one extra set of slides, which is like 2 slides, which is the end. So we are going to finish just a few minutes early, which is nice. This is the end. It's not a song. I'm just saying goodbye for now. And this is some of the more important stuff. So, like I said, it's probably easier, right? You've got the code in front of you. You can copy paste. You can move through it. We're moving very quickly. And if you're new to this stuff and you don't practice, it's hard to retain, right? Also, wherever in the world you may be going, you may be finding it difficult to talk to other people who have this skill set or who can help you continue to learn and develop. So these are some of the places that I go to for help, mostly the top 3. So tidyverse.org, the website for the Tidyverse. Do check it out. It's got a ton of great resources. It tells you all about the Tidyverse. It gives you that very technical definition I showed right at the beginning. It's got a link to this book, R for Data Science, and that whole book goes really in depth on a lot of the topics that we just scratched today, all using Tidyverse tools. Stack Overflow, a really wonderful resource. You can get a lot of help very quickly. If you're new to Stack Overflow, I would recommend just quickly chatting with someone else who's used it before, because the way you write your question can make a big difference in how quickly you can get help. But if you do it right, you can get a lot of support very quickly. For those of you who aren't into Twitter, and you like R, get into Twitter. The whole R community seems to be living there. The hashtag #RStats, this took me years to discover, by the way. It's a ridiculous thing to say, but no one ever told me this, and then I don't know how I found out. So I'm just going to tell you all now, if you don't know, #RStats, that's me at Dr. Simon J. I'm the bald guy. And I have a blog called Blogger. Pretty much everything I do is with Tidyverse tools, so if you want to see practical applications of the Tidyverse, nowadays it's mostly industrial stuff. I work in a commercial setting, so if you're interested in like big data or that sort of thing, please come check it out. Otherwise, thank you. I really do hope this was useful. Thanks for attending. I really appreciate the packed room. It's pretty awesome. Come and say hi, chat. I'm really keen to meet everyone and talk about R. So enjoy the rest of the conference. Thanks.